Promass Coriolis flow meters from Endress+Hauser are being used successfully in a wide variety of industries to provide reliable measurement of liquids and gases. Thanks to its patented and unique multi-frequency technology, Promass Q is the world's first flow specialist to offer high precision for measuring liquids containing uniformly distributed entrained gas, specifically gases that are trapped within a liquid. This measuring technology lets Promass Q compensate for entrained gas that may be present during measurement, ensuring unmatched accuracy, process reliability, and product quality in your application. Liquids with entrained gas are a common occurrence in real-world applications. Gas entrainments appear in different forms, for example, as large gas pockets caused by excessive tank stripping, large agitators, or due to long drops into tanks. Large gas pockets in a pipe cause typical flow patterns in the form of bubbly flows or even slug flows, which make it difficult, if not impossible in many cases, to perform precise flow measurement. However, through the use of suitable countermeasures in plant design, it is often possible to avoid such undesirable flow patterns. Despite such countermeasures, many liquids can still contain very small suspended gas bubbles, or even microbubbles that are unable to escape due to the high resistance forces, for example, viscous crude emulsions in the oil and gas industry. In the food industry, on the other hand, gas is often intentionally injected into liquids to achieve a specific product consistency, as is the case in ice cream or cream cheese production. Exactly for such applications is Promass Q the top specialist. But how do tiny gas bubbles actually affect Coriolis flow measurement? For a Coriolis flow meter to work perfectly, the fluid must move completely synchronized with the motion of the measuring tubes, which means that both centers of mass move in the same way. Any gas bubbles entrained in the liquid, however, affect the fluid's ability to strictly follow the oscillation of the tubes, due to the differing movement of both centers of mass. In the case of suspended bubbles, for example, the values measured for mass flow and density are therefore not correct. This effect occurs because two-phase mixtures have a significantly higher compressibility, creating a sort of mattress or spring effect. When this happens, due to the differing movement of the centers of mass, the bubbles on one side of the tube are pressed together by the oscillation, while the ones on the other side expand. This effect leads to an additional force on the wall of the measuring tube and results in incorrect values measured. For the first time, the Promass Q makes it possible to compensate for the errors resulting from suspended bubbles entrained in a fluid. To accomplish this, Promass Q uses an entirely new type of technology in Coriolis flow measurement, called multi-frequency technology. Using this innovation, a uniform primary oscillation, F1, is applied to the measuring tubes by an exciter, shown here with zero flow. To obtain more information about the liquid with entrained gas, Promass Q also excites the measuring tube to oscillate at a second, higher resonance frequency, F2. Both oscillations, F1 and F2, are thus generated and applied simultaneously with one single exciter. But how does compensation for gas entrainment using multi-frequency technology actually work? If the liquid does not contain any gas, the Promass Q measures a specific resonance frequency based on the density of the liquid. However, if a liquid contains suspended bubbles, then the resonance frequency, F1, of the oscillating measuring tubes changes due to the overall decreasing density and a higher compressibility of the two-phase mixture. Because the proportion of gas is not known, the measuring error it causes is not initially known either. To obtain more information about the properties of the entrained gas liquid, the measuring tubes are stimulated to oscillate at a second, higher resonance frequency, and here too, Promass Q measures a frequency value, F2. where the measuring error caused by the gas content remains unknown. Since the ratio between the two resonance frequencies, F1 and F2, is known, the two measuring errors have a defined mathematical relationship to each other, independent of the gas volume. By analyzing the influence of the gas content on the characteristic resonance, not just of one frequency, but of two frequencies, Promass Q is able to isolate the effect of the entrained gas and to mathematically calculate the condition of near zero error, shown here as a simplified linear relationship. This ultimately makes it possible to precisely calculate and compensate for the errors associated with suspended bubbles. With the innovative multi-frequency technology, Endress+Hauser has developed a one-of-a-kind method that allows high-precision measurement of density, mass flow, and volume flow for liquids with specific types of entrained gas, regardless of the fluid, crude oil, milk, or chemical adhesives. Promass Q gives you full control in your process at all times. This means maximum cost efficiency, process reliability, and flawless product quality. For all applications, we have the right solution. Endress+Hauser, your single-source supplier for measuring and control technology.